A curve has equation y equals f of x, where f of x equals x minus 4 bracket 2x plus 1 whole square. Okay, the curve touches the x-axis at point P and crosses the x-axis at point Q. State the coordinate of the P. So here the coordinate of the P actually touches the axis but does not cross. So we can see that f of x is a cubic equation, and this expression 2x plus 1 has a whole square in it. So this coordinate will actually touch the axis and turn back. Okay, so the coordinates of P will be 2x plus 1 equals 0. So at x-axis y equals 0, so 2x plus 1 equals to 0, so x equals half and the y coordinate equals 0, so the coordinate of P is minus half comma 0. Find f prime. That means we need to find the dy by dx. So f of x given is x minus 4 bracket 2x plus 1 whole square. So f prime x equals x minus 4 d by dx to x plus 1 whole square. We need to use the chain rule, or you can say the UV method here. So 2x plus 1 whole square d by dx x minus 4. So x minus 4, using the chain rule, 2 will come down first, 2x plus 1 to the power 1. Then again we need to differentiate the expression inside the bracket. 2x plus 1 bracket 1 is 4, 2x plus 1 plus 2x plus 1 whole square. So it will be whole square here also. So if we take 2x plus 1 as common, it will be 4x minus 16 plus 2x plus 1. So 2x plus 1 bracket close 6x minus 15, and if we simplify this will give us 12x squared minus 24x minus 15. C. Hence show that the equation of the tangent to the curve at point x equals 5 by 2 can be expressed as y equals to k. So for tangent we need to find the gradient first, and then we have the x coordinate, and we need to use this x coordinate to find the value of y coordinate using an equation here. So let's see, when x equals 5 by 2, so y will be equal to 5 by 2 minus 4 bracket closed 2 into 5 by 2 minus plus 1 whole square. So our y will be minus 54. Okay, now we need to find the gradient. So for gradient, we know that if we put x equals 5 by 2 in f of x, we will get our gradient. So the f of x, f prime, was at 12x squared minus 24x minus 15. So if we put x equals 5 by 2 in f of x, then we will get equals 12 5 by 2 whole square minus 24 5 by 2 minus 15. This will give us the gradient equals 0. Now we can use the equation of a straight line formula for getting the equation of the tangent. So y minus y1 equals m into x minus x1. So our y plus 54 equals 0. So our equation y equals minus 54. Therefore k is equal minus 54. Next part. The curve with equation y equals f of x plus a. The a is inside the bracket, so we actually can see that this translation is horizontal and it is with x. Here a is a constant, passes through the origin. State the possible values of a. So if we think about the function visually, so it is a cubic graph. Okay, it's a cubic graph that passes through x equals 4 and x equals minus half, which is the touching point that it turned back, and x cube is positive. X cube is positive, so the graph will actually look like this, and this is f of x. Now they are asking that if we translate the equation as f of x plus a, then this curve will actually passes through origin. Then what we can do here, so this 2.4 thing is, we can add half with the equation so that this maximum point will go passes through 0, and or we can deduct 4 from the x, that will make the curve passes through 0. So the two possible ways of translation is adding half with the equation, so this will be x minus half, because for x it will be an opposite way of doing the translation and transformation, and while we add 4, we will write the function as f of x minus, sorry, we are deducting, then we should write f of x plus 4. So from these two functions we can see that the two possible values of a will be minus half and it will be plus 4. This is our